Hey everybody, and welcome to another Jamovi tutorial. In this one, we're going to continue our pamlj power analysis series with the final t-test, the one sample t-test. So that's what we're going to jump into today. We are using version 2.7.5 in this recording, and you can add in the pamlj power analysis module by going up to modules, clicking on that, go to Jamovi library, and there it is, pamlj power analysis for linear models. Look at that. By Marcelo Gallucci. I have not updated the rest of mine. All I need is these, so, it works. So you click on install, you get that one, and it'll put it under this little power icon, and you can click on that. Other power analysis module packages from modules will be in this power menu, but will be divided by or categorized by what package they come from. So let's go ahead and jump into the t-test module, okay? And not independent, not paired, one sample t-tests coming up, okay? Not at all different, I want to say, from the paired samples t-test in that whatever we're going to do for our effect and parameters information is going to look very similar, right? You can see nothing's really changing here. It's even the 44. So while it may be more appropriate to use the one sample power analysis section here, tab, whatever you want to call it, it is essentially the paired samples module. And that's because they essentially follow a very similar idea, which is T has a value that goes in the numerator, which is 1 minus the other, where the other is the known population mean divided by your sample standard deviation. So, there's that, and that's essentially what a paired samples t-test is, although instead of using population mean, we're using two values and we're finding their different scores and then dividing by the standard deviation, the sample standard deviation of the difference. So there isn't a lot of different calculating going on underneath the hood here, but I'll just go ahead and tell you all of the little bits and pieces. This video is going to be significantly shorter than the paired samples, so I do recommend going and looking into that particular video, the one that dropped just before, and it goes through all of that. So in this video, I'm not going to do the sensitivity or the power plot analysis. You can go see that in the previous video. So we have one sample, but we have our population mean. That's why we're doing a one sample t-test. Well, how many people do I need to measure to ensure that I'm hitting the right effect size that is known or that I'm at least estimating, and at a minimum desired power, like 0.8, 0.9, 0.95, whatever you'd like, right? This module is far simpler than the G-Power 3.1 t-test module, whether you're doing the paired samples or the one sample t-test, right? There's really no difference. So as you can see here, if we want an effect size of 0.5, which is a medium effect size according to Cohen, at a power of 90%, so that is a type 2 error happening of 10%, right? We're going to need 44 individuals. A smaller sample, smaller effect size, excuse me, we are going to need to, we're going to put in 0.2 here for a smaller effect size. And when we click off of that, it's going to show that we need 265 people. These are the exact same calculations as the previous video. So we can see that there's not much difference here between these two. I wanted to make sure that they were in a separate video so you can see the similarities and differences, maybe? There's probably no differences, actually. If we wanted a 0.8 as our minimum desired power, so a little bit less, then you can see that we need 199, which again is the exact same from the last video. So if you watch this video, thanks so much for watching it, but you could just go with the paired samples t-test. One sample, paired sample, the exact same. So that's how you do a one sample t-test power analysis a priori in the pamlj module. If you have any comments, questions, suggestions, or other feedback, please leave that down below. I'll see you in the next video. Bye.